Hey everyone, this is KeyStrokes. Welcome back to the channel. I'm a senior software engineer at one of the FAANGs, and I like to cover interview questions like lead code problems, programming puzzles, and just anything and everything about computer science. Today, I want to talk about all the layoffs that's going on and how you can prepare for your interviews. So in this video, I will go in depth about everything you need to do to prepare for your next job interview in a matter of few weeks. And we'll also talk about some interview etiquettes, which will make the interview experience more smoother for you as well as the interviewer. I've also gone through hundreds of questions, and I will share my version of the essential questions that one needs to review to prepare for interviews. It's inspired from Grind75, Lead Code questions, and several other sources that host interview questions. I suppose this needs a name. As of now, I'm calling it KeyStrokes N questions, and it's N because this list will keep getting updated. I'm really hoping that through this video, I can help out all the fellow engineers who are affected by the layoffs, and also others if they want to be prepared for the worst, just in case. This video is targeted towards developers who have some industry experience, but I will create another video which will be targeting fresh graduates. So as experienced developers, we already know all of this subconsciously. We have prepared for interviews in the past, and all we need to do is to review all of it again before we go for the interviews again. We don't solve interview problems in our everyday job, and it's very natural to swap out all of this unnecessary information out of our brain's RAM. Towards the end of the video, I will also talk about some of the immediate steps and recommendations that one must take. They might seem very obvious, but it's very easy to forget them when we are under stressful situations. So let's jump right into it. So let's go through some of the prerequisites, which are very essential before you start your interview preparation. So the first step that you should do is pick a modern programming language. I would recommend either of C++, Java, Python, or TypeScript. And I will strongly advise to not pick anything obscure, which could make your evaluation more complicated for the interviewers, or something that's just not available on the online assessment platforms. Also, you are already a software developer, so you must be familiar with all the basic data structures, and at least know them theoretically. Those data structures would be arrays. Within it, we have single-dimensional arrays or multi-dimensional arrays, or even matrix. Then we have queues, stacks, sets, maps, linked lists, both singly and doubly linked lists. And then we have the world of trees, which will involve binary trees and array trees. And you don't have to really worry about AVL trees and red-black trees because most of the interviews, they do not ask questions around it, and we don't have enough time to prepare for these small topics anyways. And even if they ask you questions around AVL or red-black trees, you can easily derive it if you have trees as a concept clear in your mind. And the last data structure that you should know are graphs, both directed and undirected. So as a prerequisite, you do not need to know how to implement all of these and all the algorithms for them, but just understand the basics of them, what they are and what they can do, and how to declare them in the language of your choice. I won't cover each of these data structures extensively in this video, but I will give you a small brief about each of them as we discuss those topics. I will also cover some basic programs that you can write so that you can warm up on these data structures. And after you're warmed up, I will suggest going through all the interview programs that you should practice, starting from basic programs, which will be easy, all the way up to hard problems. And that should get you ready for interviews. On that note, let's see what your study plan should look like and what the next few weeks hold for you. So preparing for the interviews should be your number one priority right now, nothing else at all. If you are a family person, then please explain the situation to your partner and your kids. They will need to be your support system throughout this process. With the job, you would typically spend 9 to 5 working for the company, and sometimes it even goes beyond 5. But now it's time to replace that time with interview preparation. But if you still have your day job and you need to continue working, then I would suggest spending 6 hours on your day job and 6 more hours every day towards interview preparation. So let's see, how should a typical day look like for you? Every day, spend 2 hours to apply for new jobs. You might be applying to different roles, so make sure that you tweak your resume just a little so that it favors the job role you're applying to. The FAANG companies might not be hiring, but I'm pretty sure that so many other companies, they'll have various open positions and they would love to have all the smart minds that the companies are losing right now. Also, join community groups either on social media or through your company's communication channels and look for open positions there. You should also reach out and follow up with all of the contacts you might have, and please don't be embarrassed to use them as a resource. Also, I haven't used this, but I've heard that LinkedIn Premium is helping people to network better. I have no affiliation with LinkedIn Premium, but I just wanted to throw this out there, as this will be another resource that can help you land a job. So now we have spent 2 hours applying for jobs, following up with contacts, and just doing everything we can to land an interview. So now for the next 6 hours, I would say mix and match between learning and practicing questions for interviews. It will really depend on where you are in your journey and how you are feeling that day. And before I say anything else about practicing questions, let me be clear that I never mean to say to grind lead code. If I ever say easy, medium, or hard problems, they just indicate the hardness of the problem, and it might vary for you. The interview questions that I will suggest, they will strengthen your coding skills and be more proficient with data structures and in visualizing solutions and understanding the algorithmic patterns. A lot of these questions are found on LeetCode, HackerRank, Geeks for Geeks, and so many other websites that host these interview questions. I would never ask you to grind through any of the platforms to prepare for interviews, especially when we are in a time crunch. Grinding would only work when we are doing preparation for the long term, or if you just like to solve data structures and algorithm problems, which I really like to do. Also, the list of questions that I will provide, it will be dynamic in nature, and it will be updated frequently based on the feedback I receive from you and as more interesting questions pop up. And once you finish solving all the problems, then firstly, kudos to you for doing so. But unfortunately, things don't stop here. I would recommend you to go back, solve those problems again, at least review them and go over them until you can start visualizing the solutions in your mind and until the solutions just come to you immediately. This doesn't mean that you have remembered the solutions, but now you understand the patterns and you can just visually see how a problem will be solved. So let's see the different options I would recommend on how to use these 6 hours. So you can spend 1 hour to study the basics of some data structures that you might not be familiar with. Like if you're interested to learn how hashing works, this will be a good time. If you want to get more familiar with sets, then use this time to do so. And as you're learning the data structure, write some basic programs, like inserting in a linked list or deleting from it or constructing a tree, as then you don't have to waste your time thinking about the unnecessary aspects of the data structure. Then you can spend 2 hours to solve 3 to 4 easy problems if you'd like, or you can spend 3 hours to solve 2 to 3 medium to hard problems. Now all these 3 options that we talked about, just mix and match however you feel like, and just try to be productive and don't burn yourself out. I still have to create hundreds of videos on all of the topics and questions that I have mentioned and I will be mentioning further in the video, but it will take me months to catch up. Instead, I realized that creating this video is way more critical than me covering individual interview problems. And trust me, everything is available on the internet. We are engineers already. We can easily search around and find solutions to the problems that I will state in this video. Also, if you get stuck, please don't hesitate to reach out to me. Feel free to post your comments, email me, and I will try my best to point you in the right direction. If you need more hands-on assistance from me, then please feel free to contact me through the Google form I have put in the description of the video. I offer coaching services and one-on-ones to help you prepare for interviews, become a better coder, and just help you grow professionally. So next, let's talk about some of the interview etiquette, which are very, very important as you start taking your interview. Please dress neatly as you present to the interview, and also note that not all interview requests formals or suit, and I would recommend checking with recruiters if this is a requirement. At the very least, put on a button t-shirt and long pants or jeans and just be presentable. Before you go for the interview, make sure you understand company's culture and their values. A lot of companies like to use these as a guide to evaluate the candidates. Next, make sure you prepare an introduction, as you don't want to get flustered and think about it when you are presented with this question, as most of the interviews start this way. Just like the introduction, make sure you prepare a list of questions that you can ask your interviewer towards the end of the interview. Like, how does a typical day look like for you? What keeps you motivated to work at your current company? What technology stacks do you use? But never ever ask how the interview went and if you passed the interview. As part of the interview, many times you're presented with non-programming questions where they ask you your past experiences. And for such questions, just be honest. If you can't remember an example they ask you for, just mention that you can't think of any. And if during the interview you do remember an example, then just let the interviewer know and check if they are still interested to hear your answer. And for the technical question, please don't jump into programming right away. That's very concerning for a lot of interviewers, and you should always start with clarifying the requirements. Once the requirements are clear, quickly talk about a brute force solution if you can think of one. Make sure you call it out as brute force and that the solution won't really scale, but you just wanted to express it. Then start brainstorming a more optimal solution on the whiteboard. Start writing some base cases and some happy simple cases, and then figure out what the corner cases might be. As you start to write the program, think aloud. Make sure the interviewer hears your thoughts. This can really help interviewer understand your thought process and guide you accordingly. And once you're done with the program, do some quick dry runs. Take those base cases and happy simple cases and just run through the program with the interviewer. Also, don't forget to mention the programming language that you're using to write the code. And let's say if you can't remember some syntax like how to get the current date, then just write something similar and mention to the interviewer that you can't remember the exact syntax. And as you are dry running your program, make sure to call out any bugs that you encounter in the program, even if the interviewer doesn't catch them. There's a higher chance that the interviewer did notice those bugs and was expecting you to call them out. So as you debug the program, you show your proficiency for debugging and how to fix any code. And as you wrap up your technical question, mention the time and space complexity and any unit test that you'd write to test the functions. So this is everything that I'd expect when I'm the interviewer, and it just eliminates any concerns that might get raised to the interviewer. Next, let's jump into data structures and cover them briefly. So the first data structure is arrays. It's a linear data structure, that is, the data is stored sequentially, and it's a collection of similar type of data like arrays of strings or integers and so on. The size of an array is static after it's initialized in most of the cases, and you access an element of the array using an index which starts at 0th position. All the data of the array is stored in contiguous memory locations. So when you declare the array, a chunk of contiguous memory is reserved for the array. Arrays can be single dimension or multi-dimension, which then leads into matrix. Let's talk about some of the time complexities. It takes O of 1 to access an element, O of n to traverse them, as you need to access every single element. It can take O of n to insert an element because you might have to shift the elements, and similarly, if you delete an element, it might take O of n to shift the remaining elements. Inserts and deletes can be O of 1 as well if you're not shifting rest of the elements and all you're doing is clearing or appending to an array. Arrays are very useful when you need to create a fixed size collection of similar data types and you need to access them quickly. Some of the programs I'd suggest practicing to warm up on arrays is how to pass arrays to functions and how to create, populate, and iterate on the arrays. There are some other fun programs that you can write to warm up on arrays are how to reverse an array or rotating an array, trying to search, insert, and delete in a sorted array, and even trying to traverse a matrix using recursion. The next data structure are queues. These are linear data structure as well, and they store data sequentially, but this time these can be dynamic in nature, and they follow the concept of first in, first out. That is, the first element that goes in is the first element that comes out. And this is something that you actually see in the real world a lot. Any place where we line up, let's say for coffee, or just any line that we create for checkout, that's basically how a queue works. Some of the common operations for queues are enqueue, which is when you insert an element to the rear of the queue. Then we have dequeue, where you remove an element from the front of the queue. And you have peek, where you check what's in the front of the queue. Queues can be implemented as an array or linked list. And the time complexities for enqueue, dequeue, and peeking are all O of 1 when we use the linked list implementation. This is a very good data structure when we need to process things in order or when we are performing breadth-first searches. The most simple program you can write to warm up with queues is to implement queues using arrays. If you want to make it more challenging, try implementing a circular queue. Next, let's talk about stack. This is very similar to queues in terms of it being a linear data structure where the data is stored sequentially. It's dynamic in size, but this time it follows last in, first out principle. That is, the element that goes in the last comes out first. Now again, we see this a lot in the real world. Every time we have a stack of books or a stack of papers, that's literally the same stack we are talking about here, where anything we put on top is the first one that we take out. Some of the common operations are push, where we insert the element to the top of the stack. Then we have pop, where we remove the element from the top of the stack. And we have peek, where we check the element that's on the top of the stack. Now this can be implemented as an array or linked list as well. And the time complexities are O of 1 for push, pop, and peek for a linked list implementation. Now, this is a good data structure when we are performing DFS, and this is actually used for function call stacks. Similar to queues, a good program you can write here is to implement stack using arrays and practice operations like pushing, popping, and peeking. Now, getting to some more fun data structures. Let's talk about linked list. Linked list is a linear data structure as well, where the data is stored sequentially and they are stored in individual nodes. The nodes are connected to each other, which makes it a linked list. This was dynamic in size as well, that is, it can keep growing if needed. And some of the common operations are to insert, where you insert a node at a position, or you delete a node, or you traverse through the whole linked list. Now, this is a very good data structure when you need to manage some large sequential data where the size is dynamic. And this data structure becomes even helpful if most of your operations are on the ends of the list. I will recommend creating a simple linked list and practicing inserting, deleting, and traversing it. And you can write a lot of programs through recursion or iteration. Next, let's talk about trees. It's our first non-linear data structure where the data is not stored sequentially. It's again dynamic in size, but trees store hierarchy of data, which are organized as nodes with a parent-child relationship. The time complexities really vary depending on what kind of trees you're dealing with, but generally inserts and deletes are O of 1 and traversing is O of n. It's a very good data structure to use when you're working on hierarchy of data, and some of the common algorithms that we use with trees are BFS, DFS, and several traversals. Some good programs you can try are constructing a simple tree, doing pre-order, in-order, and post-order traversals, doing level order traversal, trying to insert and delete in a binary search tree, and trying to find the depth of a tree. Next, let's talk about a more complex data structure, which are called graphs. This is a non-linear data structure as well, where the data is not stored sequentially. It's again dynamic in size, but this time this stores interconnected data, which are organized as nodes and connected using edges. Time complexities for graphs are generally O of 1 for insert and deletes, and O of n to traverse through the whole graph. It's a good data structure to use when you're working on data that are connected to each other. And if you think about it, trees are just a subset of graph where they do not have any cycles. Some of the common algorithms are BFS, DFS, cycle detection, shortest path between nodes, and just a bunch of other algorithms. To practice graphs, I would recommend constructing directed and undirected graphs and perform BFS and DFS traversals on them. You can also look at several algorithms like Dijkstra's algorithm and Bellman-Ford algorithm to practice how shortest path between nodes are evaluated. Some of the other data structures I want to talk about are sets and maps. These are used in tandem with other data structures to solve problems. So let's start with sets. Sets are non-linear data structure where the data is not stored sequentially and it's dynamic in size as well. The unique property of sets is that it only stores unique values. That is, it doesn't have any duplicates. Usually it's implemented as a tree internally, and the time complexities are O of 1 for adding, deleting, and checking if something exists on the set. And iteration is O of n because you need to go through all the members of the set. It's a very good data structure to use when we need to maintain uniqueness in a data set with performant lookups. The last data structure that we'll cover are maps. I think sets and maps are the most used data structures when solving problems. And as for maps, they are non-linear data structure as well, where the data is not stored sequentially. They are dynamic in size, and they store a key and a corresponding value. This is implemented as a tree, or they can also be implemented as a hash table. And the time complexities is very similar to sets, where it's O of 1 to add, delete, or check if something exists in the map, and it's O of n to iterate through everything in the map. Now, maps are very useful when we need to store something against a key and perform quick lookups. So this was all the data structures that you must know, and most probably you already know about, and we'll be using these to solve a bunch of interview problems and get you ready for your interviews. So now that you know your data structures, it's time to practice interview questions. I have compiled around 80 questions which I think are worth practicing before you go for your interview. I have tried to classify them as easy, medium, and hard problems, and I tried to classify them further to the corresponding data structures. I will recommend you to solve the easy and medium problems first, and once you're done with them, go with the hard problems. Once you are done with all of these questions, I will suggest going over all of them again, but this time you don't have to write the programs from scratch. Just go over it, read the question, Visualize the solution in your mind. If you're having a hard time visualizing the solution, and if the solution just doesn't come to you naturally, then maybe you should try to write the program again and spend more time studying that question. Once you solve these problems, you will have improved your chances of passing the interview considerably. We still have a big factor of luck involved in interviews, but we do whatever we can, and practicing these questions is one of them. Also, please don't forget to take breaks. I know there's a lot of mental pressure, and solving these questions can get boring at times, so take some days off if you need to, and spend some time with your friends and family. And before I wrap up this video, I want to share some of the recommendations I have as for the immediate steps you should take if you were laid off. If you're on a visa, then please figure out your timeline. Talk to immigration lawyers and see what are the next steps you need to take, and basically how much time do you have before you need to find your next job. Try to cut down on your costs temporarily and make sure you have enough funds for the next 6 months. Try to join some social networking groups where you can learn about job openings, and you can find these groups on social media websites and in your company's communication channels. Try to make more contacts through them. I've seen several groups where people share their LinkedIn contacts and are open to being contacted for any help that you might need. Be proactive and reach out to the contacts. Don't be embarrassed at all to reach out to them, and ask for helps and referrals ASAP. And make applying for jobs a part of your day. Spend 1 to 2 hours every day on this. Even if you see similar job openings, just apply to them. Tweak your resume as needed, and make sure you're spending time on this part of the process. And of course, keep preparing for the interview. This will be your new full-time job until a company gets lucky and hires you. And please, let's make our mindset strong. I know things have become very uncertain now, and I'm not going to ask you to relax, because this will be a high time for you, and I'll rather ask you to be strong and to work through it. We are software developers, and we have been through the worst times of our life, especially during those projects with tight deadlines, and even in college when we had a course that we couldn't understand at all. As a software engineer, we are problem solvers by nature, and we will solve this problem as well. Just give your best, as this is the best course of action that we can take. If you know of any job openings, please don't forget to post them in the comments and help out the community. And please feel free to share out any resources that you might have. And if you need more help, please don't hesitate to reach out to me using the form that's in the description. Good luck to everyone in preparing for the interview. I'm sure we will all succeed. Thank you so much for watching this video, and please don't forget to like this video and subscribe if this video helped you. See you next time.